All right, so first, we're going to go over logical forms, logical equivalence. So I like this quote at the beginning of the section. I'd like you all to read 2.1 and 2.2 before I see you next time. We'll try our best to finish 2.1 today, but we'll see how it goes. So this quote by Immanuel Kant, he said, logic is a science of the necessary laws of thought, without which no employment of the understanding and the reason takes place. So we're going to be going deep into logic, little by little, and then we're going to apply it to different things, okay? So the first thing we want to talk about is arguments. So an argument is just a sequence of statements aimed at demonstrating the truth of an assertion. So basically any statement that has we'll talk about statements in a second, the actual definition. But right here is a basic example of an argument. So we'll just talk about this. You don't have to write this down or anything. I'm gonna send it to you right after. So if the bell rings, or right, there's an important piece there, the flag drops, then the race is over. So what I want you to start being able to do is break down the pieces of the argument into separate statements. Okay, so this is what we did, what I did earlier while I was waiting around. So the bell rings is one statement. So I'm calling it P. So we get used to it. Q is the flag drops, so that's a different statement. R is what happens, right? Then the race is over. So if the bell rings or the flag drops, then the race is over. So I called it P, Q, and R. And just so we get used to negation, not P means the bell hasn't rung. Not Q means the flag doesn't drop. Not R means the race isn't over. Okay. So you can actually negate this, and we're going to go through that later. Something called the contrapositive. So I can switch it and say, if the race is not over, then the bell hasn't rung and the flag hasn't dropped. See how this switched to and everything is negated to not. So if you switch everything and negate them, then you have an equivalent statement. So both A and B statements are logically equivalent. And we'll talk about what that means in a little bit. So a more simpler math example would be, by the way, these means therefore right here, the symbol. So if P, right, if X is equal to 2 or X is equal to -2, then X squared is equal to 4. So it's just an argument, right? So now if we negate it and put this in the beginning, right? See how we're switching this guy to the beginning and putting these two at the end, but switching it from an or statement to an and statement. So when you do this, this is considered to be a contrapositive here. So they're both logically equivalent. So notice how we have if X squared is not equal to 4, then X cannot be 2 and X cannot be -2. This is the same as that, right? Logically. Does that make sense? But these are my P's, so this is like my not P. Actually not R. This is not P and not Q. Okay, so now let's do an actual example together. But before we move on, do you guys see what the parts of the statements of the argument are? Do you see how this is P, Q, or how P is the bell rings, Q is the flag drops? Is that clear?
Yes. So with the contrapositive statement, does that mean like, so if not R is true, then does that make not P and not Q both true as well?
The entire statement, let's suppose that this first one is true. So this entire thing would be considered to be a true statement, a true argument. That would mean that the contrapositive would also be true. But if this is true, the negation would become not true, the separate pieces themselves. But as a whole, they would be logically equivalent. So they would both be true or both be false.
Gotcha.
But these pieces will not be, well, are technically the opposite, right?
Right. So it's not guaranteed that the pieces are going to be true to each other, but the entire statement will be.
Yeah, it will be the same as the original.
Okay. Thank you.
It's like we did with the bell here. Notice how we said if the bell, so let's picture like a race or something, right? If the bell rings or the flag drops, then the race is over. So if the race is not over, then that implies that the bell hasn't rung and the flag hasn't dropped, right? You see how that's the same thing? Logically, it's the same thing. Sorry.
Right.
It's the same thing here, same deal. So this would be not equals to, not equals to. These little three dots means therefore when you read the book. This will be used to replace therefore. So this, therefore, this. Okay. So now let's do some work actually together. The next page here. Anyone have any other questions on this first little part here? I wrote the definition as well. This class is gonna have a lot of definitions, so make sure you study them and understand them. That's gonna be the key to, figuring this class out. Definitions are a big deal. So let's solve some problems here. This is example 2.11 or 2.1.1. Identify the logical form. So in English, it says, I want you to change these to P's and Q's. Okay, so if Jane is a math major or Jane is a computer science major, then Jane will take math 150. Whatever 150 class is, who cares? So let's start by labeling what P is. So what is P for statement A?
Jane is a math major.
Yeah,
Or
Jane
math major.
is a math major. That's right. Okay. So what is Q?
Jane is a computer science major.
Yeah, so or Jane, yeah, that's right. Jane. So there's two statements in there in this argument. Jane is a computer science major. Okay, and then what is R? What's the last piece?
Jane will take math 150.
Yeah. Is there any confusion about that? Do you guys see how to convert it from English to P's and Q's? We're breaking down the statement into logical form. So let's put it all together, right? I'll do this one for you guys. So if, let me make a space there. I'll put it up here. So if P or Q, then R happens, right? So that's the mathematical first attempt to change it into logical form. Does that make sense?
Yes.
This is one more. If logic is easy, or, right, it separates the first statement, I will study hard, then I will get an A in this course, right? So what is the first part of this argument? First part of the statement. First statement B.
Logic is easy.
Yeah, so logic is easy. Second part,
I will study hard.
yeah. And finally, we get we'll get an A in this course. Does anyone have any questions on how to break this stuff down?
Not really.
Okay. All right, let's see here. Okay, let's change it to so if P or Q, then R happens. All right. Here's another definition. A statement or proposition is a sentence that is true or false, but not both. So P can be false or true, Q can be false or true, R could be false or true, but not both. Okay. Has to be one or the other. And then the statement as a whole, of course, or the argument as a whole can also be true or false. Okay. You guys cool on this page?
Yep.
Okay. Let's go over some notation and then we'll do another example. Pull out the book real quick. All right, so or is the same as this little V symbol. And is the opposite. All right, so the way I remember is this kind of reminds me of an A, so that's and then the other one is the opposite. That's all I remember in my head, but I mean, whatever helps you, you can think of it however you like. If you see the statement, P, oh, actually, I'll write it down here, I guess. P but Q. That means P and Q, which is, this symbol here. If you see neither P nor Q, that means and this is a symbol for not P. and not Q for this book. Take a little tilde. Okay. So that's all notation for now. Well, let's try this example here. So 2.12, translate from English to symbols. Write each of the following sentences symbolically. Letting H equal, it is hot, and S equal, it is sunny. So statement A, it is not hot, but it is sunny. Okay. So it wants us to use H for hot, right? This is not hot, so that'll be not H for sure, right? It is sunny, meaning you would use S. Remember at the beginning, but up here we said that if they say but, that is the same thing as saying P and Q. So it is not hot, but it is sunny. So it's saying, in other words, right? This is a Latin for it est, right? That is to say. That is to say, it is not hot, and it is sunny. So therefore, in symbols, we would say not H and S. Does that make sense? How we got to the symbols?
Yes.
Let me know if something seems off or you don't remember or something doesn't make sense. All right, so part B then. It is neither hot nor sunny. So that's the same thing as saying not P and not Q. So that is to say, it est it is not hot and not sunny. So symbolically, that would be not, what would you guys say for the symbols? Can you guys convert this to symbolic notation?
H, it will not H. And then it'll be the same as above. We'll have the upside down V. And then we'll also have another squiggly because it's not sunny as well. And then S.
Not H and not S. That's right. Is that clear? Is that anyone have questions on example 2.1.2, beginning or the end, doesn't matter. Is it okay?
You hear me? Yeah, okay. Is that a squiggly or is that a negative sign?
It's like a
minus-
tilde on the
a
keyboard.
tilde. Okay, okay.
Yeah, I just can't write with anything. It's one of these guys.
Gotcha. Thank you. I just wanted to make sure for like future.
Yeah, no worries.
Can you scroll up?
Mhm.
Thank you.
Did you get the top part?
Yes.
Okay. Alrighty. Let's move on to two. Well, first I'm gonna give you some more notation, and then we'll start another example. So you guys are all good on this example. Okay. Assume silence is pros. Okay. So let's do some more notation, this time for inequalities. So you guys, I'm sure you guys remember, pretty sure you've all taken some math before. X less than or equal to, what's the letter here? A. X less than or equal to A means X is less than A or X is equal to A. So it's actually an or statement. If you were to see this guy here, A is less than or equal to X, which is less than or equal to B, that means A is less than or equal to X, and X is less than or equal to B. So that would be an AND statement. Okay, so for 2.1.3 and or inequalities, suppose X is a particular real number. Let P, Q, and R symbolize X is greater than 0, which is the same as saying 0 is less than X, if that's easier for you. X is less than 3 and X is equal to 3 respectively. So that's P, Q, and R right here. P, Q, R. So write the following symbolically. So same thing as we did before, but now our statements are mathematical statements instead of English statements. So how do I write this in symbols? Part A. Using P, Q, and R, etc. All right, so X is less than or equal to 3. So we said that this is, so we said X less than 3 is Q, and this is equal to 3 is R. So let's rewrite this into the symbols up here up top. So this means that is to say, id est X is less than 3 or x is equal to 3. So symbolically, that would be to say Q or R, right? Does that make sense?
Right. I'm guessing instead of or, we'll use the V.
Yeah, we should. Let's do that. That was just me being weird. Okay. Now part B, 0 less than x less than 3, or in other words, x is between 0 and 3. So using this information up here will help us a little bit. So that is to say that 0 is less than x and x is less than less than 3. So in symbols, that's going to be, right, this is what? Right, this is, respectively, this is going to be P. This is going to be Q right here. So P and Q. So that is to say P and Q. Is there any questions with example 2.1.3 so far? Okay, then let's keep going. So similar to B, this is the same thing except there's an equal to part here, right? So it might be a little more complicated because this means something else. So let's see what happens. So that is to say that 0 is less than x and x is less than or equal to 3, right? But this is an or statement already. So there's an P and this guy, but this guy is two things. So that would be to say that 0 is less than x and, in parentheses, x is less than 3 or x is equal to 3. You see what I mean? This is a little bit different. So this is really saying P and Q or R. So it's has 3 pieces. Does that make sense? You guys cool on part C? Here's a definition. I'm going to be using the word truth values, or the book will. Whenever you hear that, that just means we're assigning a value of true or false. So it's nothing complicated. Definition here for negation. So if P is a statement variable, meaning P represents some statement, with negation of P, that's denoted as meaning not P, right? So the negation of P is not P, or it is not the case that P, so however you want to write it, right? So, and then it is denoted as not P, so there's a symbol. So not P has the opposite truth value from P. So whenever you're filling out a table, so we're going to start doing truth tables. So if P is true, the negation means it must be the opposite. If P is false, the negation must be that it is the opposite. So that's what I mean by negation. So if this was like, I don't know, X is equal to 3, then this is X is not equal to 3. It is the opposite. Okay.
Wasn't there another variable that it could be? Wasn't it like neutral or?
You mean the P itself?
No. I'd have to pull out my binder from prep, but I don't know. The truth tables, like they got super complicated and confusing very quickly. I can't remember what it was. It was just like, it was like one thing that just completely changed it.
Yeah, I mean, they are going to get complicated little by little. Right now, it's just a basic P. This is the only, well, I don't want to say only, but P will only be true or false here. And the way we defined it, we said a statement has to be one or the other, right? Any questions on the definition of negation of P? Or not P, in other words?
Can you repeat again, Tom?
What's up?
Can you repeat it again?
Sure, yeah, so if P is a statement variable, the negation of P, in other words, not P, you can also call it, it is not the case that P, you write it this way, not P. So not P has the opposite truth value from regular P. So true and false, negation must be the opposite, must have the opposite truth value as false and true. So always be that way. Okay. Are you guys cool on this page then? I'm gonna turn the page. It's gonna start a different, we can start talking about conjunction, sorry. Right. Here's a definition. I'll give you time. If you want to write it, you can, but let's go through it together. So if P and Q are statement variables, the conjunction of P and Q is, in quotations, P and Q. So conjunction means the and statement, okay? So, and we've denoted it as P with this symbol Q, P and Q. This conjunction, this type of statement, it is true only when both P and Q are true. If either P or Q are false, then the conjunction is false. So both have to be true. And this is something that I'm sure we all know when we speak in English, right? If both are true, that is the only time the and statement is true. Okay, so if one of them is false, the conjunction is false. So these are all the possibilities. If both are false, well, it doesn't change a thing. It is only true when both are true. So this is the truth table for P and Q. Okay, so let's think of a basic English example, right? Let's say we are let's say I'm wearing, let's say I said, you know what? I am wearing pants and shorts. Like, or you are, it is currently raining and not raining. So right away, those things are opposites. So they can't happen at the same time. So as soon as you see that one part is false, then the entire thing is false. Right? If I told you I'm rich and have no money, am I what? That's false, right? That and requires both parts to be true. Like if you said, oh, I have a job and I have money, then yeah, that's true, I guess. Because both parts need to be true. So that's how and statements work. So whenever you use the word and, you better make sure both parts are true, right? If you're trying to say a true statement. Otherwise, they may come out silly or false. Or the or statement's a little bit different. So if P and Q are statement variables, the make sure I wrote that right. Disjunction, yeah. Disjunction, that's a J, of P and Q is P or Q. So whenever you hear disjunction, we're talking about the or statement. And we write it this way, denoted as P or Q. It is true. So this statement is true when either P is true or both P and Q are true. So as long as one of them is true, then the entire statement is true. This one's a little easier to make sure you're correct or true, right? So if one is true or both are true, then it's true. If one is false, it's still true. If one is false, still true. Only false when both are false for the or statement. Okay. So even if both parts are contradictory, it doesn't matter. As long as one of them is true, then the entire statement is true. So if you said, I am alive or dead, I'm like, well, yeah, I guess that's true, even though you can't be both, right? Technically, that is true. You know, if I said tomorrow it's going to rain or not rain, I'm like, well, yeah, that is true, but doesn't really help anything, right? So as you can see, as long as one piece is true, then you're good. Right, so that's the disjunction, the or statement. Is there any questions about the and or statement? Okay, so let's move on to something else. You guys cool on this page? Okay. I'm gonna write the definition of the next one. I didn't have time to write it out. So a statement form, also known as a propositional form, is an expression made up of statement variables and logical connectives. So stuff like negation, or, and, that becomes a statement when actual statements are substituted. So basically, if you have it on, and if you have everything in symbol form, if I substitute actual statements like words, it should still be a statement. That's what we mean by propositional form, statement form. Substituted for the component statement variable variables, sorry. It looks ugly. The truth table for a given statement form displays the truth values that correspond to all possible outcomes of truth values. For its component statement variables. That one's a long one. For its component statement variables. Okay. Sorry, so a lot longer than I thought it would be. So next example, truth table for the exclusive OR. So example 2.1.4 is the truth table for the exclusive OR. All right. So the exclusive OR table is actually this guy. So that is to say, find truth table for P or Q and not P and Q. So let's make a big table here for this example. So I'm going to put P over here, Q, P or Q, P and Q, not P and Q. And then finally, put it all together, the answer, P or Q and not P and Q. Oops. So let's do piece by piece in order to answer this question, in order to come up with the truth table for this guy. So P can be true, Q can be true, right? Whatever. If they are both true, then the OR statement, as long as one of them is true, we said this will be fine, right? What about the AND statement? If they are both true, what is P and Q going to be? Yeah, true. And then the negation of this guy would be the opposite, right? So what would this be? It has to be, right? Okay, so let's try to put it together. P or Q and not P and Q. So this guy and this guy, so true and false. You see that? There's the both pieces. So what is this going to be? What is true and false?
Is it like regular math where you use a negative and a multiplication? It's just negative. So this would be false. Like you use
Kinda.
I mean, obviously it's because it's and too, but like
Are you talking about why it's false?
the final one, you said both together.
Yeah, yeah. So we have these two pieces, right? These are right here, right?
Right.
So we just gotta put them together. So what happens when you have true and false? They just disregard this at this point, right? Looking at these values, what is true and false? For an and statement, we said it's only true when both are true, right? So one of them is false. You see what I mean? Because this looks complicated, but if we look at it as just one value and another value, we follow the basic and statement definition. Is that clear or is that weird? Remember, we need to remember the definitions, right? What is the definition of the conjunction, the and statement? That's why we came up with F. And these are all dictated by these first two choices. So now if this is true, but this guy is false, we have to refine all these pieces. So true or false? What is the statement, right? Yeah, has to be true. True and false. Right, it has to be false because and statement we said both need to be true, correct? Now negation means opposite, so negate this guy, so the opposite will be true, right? Once you have these pieces, you can answer this question. So now we have true and true. So true and true would be true, right? Does that make more sense?
And we're going to be doing truth tables.
Yeah, you will.
And when do we know when to stop? Like,
Well, there's only two possibilities, right?
Okay.
Like when you have P and Q, there's only 4 combinations.
Right.
So we're gonna have
But so you do all the combinations though. That's what you're trying to do.
yes, all of them. So these are all of them right here, right? So false and true, false and false. The last two. So false or true. It has to be true. False and true has to be, right? If one of them is false, we've said false. And then this guy is just a negation of this one, to swap it. So what is the final piece for the third combo here? So we have true and true. So it has to be true. Yeah. Does that make sense to everyone? Okay. All right, so last one here for this exclusive or. False or false, well, has to be false, right? False and false, well, that has to be false. The opposite of that and statement has to be true. False and true has to be false. Yeah, thanks. Is there any questions on 2.1.4? Okay, let's do another truth table. 2.1.5. Find the truth table. This time we'll have three possibilities, three statements for P and Q, or not R. So it's best to build it up little by little, just like we did up here. Notice how we didn't go straight for this question. We did the basic P and Q, all the possibilities. Then we had the or statement, the disjunction, the and statement or conjunction, then the negation of the and statement, because that's what we needed. So over here, we're for sure going to need an and statement, and we will need a negation of R. We don't need the or statement, right? Technically. So all we need is the and the negation. And of course, the P and Q, PQR. So here we go. The P, Q, R, and then we said we need the and statement. So P and Q. And then we need the negation. Once we have these pieces, we can answer the question, which was P and Q or not R. To find the truth table for that argument. Okay. So let's use the same combinations, I guess. So if P is true, Q is true, and let's say R is also true, the and statement will be, since they're both true, then we're good, right? What is the negation of R? Yeah, you just swap it, right? False. Okay. All we need is, we don't need every single possibility, but yeah, let's go through a lot of them. Let's say these are both true, but the second one is false. So the and doesn't change, so we'll ignore that part. So not F would be not true, would be true. I'm sorry, not negating a false statement would be true. Okay. All right. Let's do true then false for Q. I honestly don't need any more of the R's. So I'm just not worry about it. Because all we need is those two combinations, but well, actually, let's go ahead and keep going. It's fine. True, false, true. So and statement true and false, they both must be true. So false. Opposite would be of R, that would be false. True, false, false. Again, one of them is false, false. Negation would be true. Okay. Okay, what's left here? I think we're about halfway on this guy. True, false, false. We got false, true, true. Right? One of them is false, so false. Negation of true, false. False, true, false. Again, one of them is false, so false. Negation of false is true. False, false, true. False and false, of course, is false. Negation of true for R is false. Triple false. False and false. False. Negation of false, true. All right, so we did all of them. That's 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay. So now, since we got all the truth table values, let's keep going here. So P and Q or not R. So for or statements, we said as long as one of them is true, the whole thing is true, right? So there's the and statement. So true or false has to be true. True or true, true. False or false, well, that's false. False or true, true. As long as one of them is true, we're good. False or false, false. False or true, false or false, false or true. Is there any question as to why the and statement is true or false, or this final answer? You guys okay?
Yep.
Not too bad so far.
So far.
All right. I think we're just about out of time. So what I want you to do again is read 2.1 and 2.2. Just, I'm not saying like master it. I'm just saying, look it over. And just be exposed to it. That way, when we talk about it, it's not completely foreign to you. You know what I mean? That's the secret to doing well in math. I never listened, but I wish I did. My professors would always tell me, read the book, then come to class. I never read the book, and then I was always lost during class. So I recommend you read it. It's good for you. Let's see here. If you're, as far as your question, Joseph, let me see 1 second. So basically, propositional form is just a complex statement using only symbols that can be substituted with words and still be an actual statement or argument. That's all that this was saying. I know this is like a long definition, right? So all this is saying is that if you have something like, let's say this guy right here, this exclusive or this one, the fact that we could change this back to an actual paragraph or some sentences and it still makes sense, that means it's a propositional form. All right, so we'll finish off 2-1 next time and see how far we get in 2-2. I haven't, can you get to the book, David? With that link that they have right now or no? If not, I'll have to make something. I mean, that's fine. I mean, I didn't tell you to do that, but I don't care if you do. But feel free to throw it in the chat for everybody. Anyway, yeah, libgen's nice. But yeah, if you want to use, check if you're using the actual ebook, let me know if you can see it through that link. Okay. Okay, Marilyn. I'll mess with it today. I think I need to add some extra stuff. I'm not sure if I'm going to assign actual homework out of there, so I haven't set it up. I just want to make sure you can get into it. But let me add some things. Okay. But I will let you know soon. But for now, still have like halfway done with 2-1. So it's surprising. Yeah, let me mess with that book and then I'll post maybe some starting homework problems, okay? And I'll scan this and send it to you in a couple hours.